right, here we go, everybody, and welcome. Okay, so this is calculus. We're just going to start at the beginning of the course and exam description, and we are just going to go straight through. Um, so section 1.1 has this question: Can change occur in an instant? Now, the ideal thing before watching this video would be to have a discussion, if that's possible, um, in class about this. But after that discussion, watching a video like this might be good to kind of put everything together. So let's talk about it, right? So first, can a change occur in an instant? Let's make sure that we're thinking about this the right way. Calculus doesn't have to be complicated. Let's say I have just x-y axis here, and let's say that this curve that I'm getting ready to draw here in this red color, let's say that, I don't know, let's say this is like a roller coaster or something, right? Roller coaster, right? So roller coaster comes up, has a huge first drop, and then it comes back down. And you know what? Let's just say that that's it for the moment. Um, you know, all right. Just sort of extending the x-axis out there. So what I want you to think about is I want you to think about being on a car in the roller coaster, right? So as you know, you're coming up here. So at some time you're here. At a later time you're here, right? Now let's concentrate just at this moment in time. So we're just looking at when we're right here, and let's think about what is happening at that instant. If we were to take a photograph, if you were to look at the photograph, you wouldn't see any motion because, of course, it's a photograph. But if you were to ask, well, what is this photograph capturing? What is happening in this photograph? And if this is a properly functioning roller coaster, then what would be happening is the car and everyone in the car would be going up the track. In other words, everyone would be increasing their height as they go up the track. And thinking about this is what we mean about change at an instant, right? So at one moment in time, what is happening? Are we increasing? Are we decreasing? Are we going up? Are we going down? Um, or are we staying the same, right? So, it could very well be the case that instead of the situation that I've drawn here, we could have this situation instead, right? It could be that we've already hit the top, so well, maybe we've already cleared this, and maybe we're here now. Maybe we're just cruising along the maximum height of this little area here, and um, you know, if you were to ask about the change in height here, if you're going straight, in this instant, there is no change in height here. No change in height here. Like I said, of course, in this case here, we're increasing. And then, of course, we could be over here. We could be on the other side, and we could be going down, right? And so if we capture a moment in time here, then the car and everybody in it is going to be going down this way. In other words, everyone will be their height will be decreasing. Okay, and these are basically all the situations for the most that happen for a function. The function can either increase or decrease, or it can stay the same. Um, let's discuss. Let's see. Let me make sure I'm not missing anything here. Okay. Um, let's discuss very quickly the case of a vertical line, right? So x-axis, y-axis, and if I have something like this, if I have a vertical line straight up like this, okay, let's say for example that this is 1, 2, 3, let's say this is x equal 4. Okay, now the thing to understand about this is that, you know, I don't know, let's say you're here. There is no way to travel left or right. There's no way to travel left or right, and similarly, because this happens at 1x value, it is impossible to say if this point is traveling up or down. Right? So, you know, for that reason, you know, the rate of change here, the rate of change is undefined here. Okay, rate of change here is undefined. Good. Another way. Okay, let's talk about this just for almost missed something here. Let's say you know, if we consider these 2 points, right? The rate of change is undefined, and what that means in this case is that the rate of change is either plus or minus infinity. Okay, and the reason for that is, you know, imagine again, you know, imagine if you're down here, and imagine if you have to go all the way to the top. Imagine if you have to go all the way to the top of this line before you can move to the right. What you'll find is that you'll be going up forever because the y values go all the way to infinity. Okay, and they also go all the way to infinity in this direction. So, you know, if you're sketching up or you're sketching down, you're going to be sketching forever, and you'll never be able to escape this line. So let's keep that in mind as well. Okay, so sort of a little algebra review here. Let's see. Let's introduce just a little bit of terminology. And that is, let's see. So increasing, right? Let's get a little bit more mathematical. Let's talk about what we mean by increasing, right? So increasing means as we go from left to right. As we go from left to right. In other words, as x increases. As x increases, y increases. That's what we mean by increasing. Here, by decreasing, what we mean is as x increases. I'm going to abbreviate. As x increases, y is y going up or down here? If we're sketching from left to right, y is decreasing. Y is getting smaller. Okay. Now here, no change. What this means specifically is as x increases, y remains the same. Okay. All right. Good. In this case down here, right? Here, x cannot increase or decrease. But y, oh, sorry. But y can be anything.